Well, it's been about 2.5 years since I completed the CNC machine, and I've been asked several times if I had a wiring diagram for it. And I didn't have much to go on when I built it, so with all the requests I decided to go ahead and make a drawing of the way mine is wired, and so hopefully it'll help somebody else. And also in the description below I'll include a link to Dropbox where you can download a copy of this drawing. So let's come in here closer and take a look at how it's wired. Okay, let's take a closer look at the components on the wiring diagram drawing, and then we'll take a look at the actual components in the electrical panel itself. Start out, we have an illuminated switch, 2 power supplies, 4 drivers, 4 stepper motors. We have a breakout board. We have some home limit switches, 3 of those, 1 for each axis, and we have 3 e-stops. Also, we have a 120 volt outlet coming off the main power from the last power supply. We have a 120 volt fan, and we have a 5 volt plug-in power supply that goes to the breakout board. So let's take a look in the panel and look at those same components and see what they look like. We have the 120 volt power coming in to the panel back here, and that goes to the illuminated switch on the front. Then we have the 2 power supplies. Then we have the 4 drivers, 1, 2, 3, 4. Then we have the 4 stepper motors, which are on the machine itself. Then we have the breakout board, which is kind of hard to see. Back here is the breakout board. Then we have the 120 volt outlet and the fan. Components that are not in the panel, of course, are the stepper motors. There's the X-axis stepper motor, and up there's the Z-axis motor. Back here under the table is the 2 Y-axis stepper motors. Right here is the home limit switch for the Y-axis. Over here is the X-axis limit switch, home limit switch. And there's the home limit switch for the Z-axis. Then also we have the 3 e-stops. There's one on this side of the machine, and we do have one on the panel itself, right on the front of the panel. And I have a 3rd e-stop on the other side of the machine, just for convenience. Okay, now we get down to the actual wiring. The 120 volt AC comes in to the panel. The hot goes directly to the illuminated switch along with the neutral. Ground goes directly to the first power supply. Then the hot leaves the illuminated switch and goes to the first power supply. The ground goes to the ground terminal. The hot leaves the illuminated switch, goes to the line terminal, and the neutral leaves the switch and goes to the neutral terminal. Now, if this were not an illuminated switch, you wouldn't need to run the hot and the neutral through the switch, but because it's a lighted switch, you have to have a hot and a neutral. Now that the first power supply has the 110 voltage with the hot, neutral, and ground going to it, these are 36 volt DC power supplies. We take the same 120 volt hot and neutral and ground and run up to the second power supply to supply it with 120 volt, with the hot leaving the line going up to the line terminal on the other power supply. Same with the neutral and the ground. Here's a visual of the actual wires going from the incoming power. Leaves the incoming power, travels along along the path in front here to the illuminated switch right here. It comes back the same path to the first power supply here. Jumps from the first power supply over to the second power supply right here. Now on my machine, since I have two power supplies, I'm using one power supply to feed both Y-axis motors and the second power supply to feed the X-axis and the Z-axis. Now all the drivers and stepper motors are wired exactly the same. We'll run through that right now. On the power supply, you leave the power supply with volts DC, and I've got a red wire going to volts DC plus and volts DC plus from the power supply to the driver. And here's the volts DC going to the second driver to volts DC on the driver. Then you have a common going from the power supply to the ground next to the volts DC on the driver, and the common here going to the ground on this driver. Common and ground are basically the same in DC. Same thing on the other power supply, the volts DC going to volts DC on these other two drivers, and the common leaving the power supply going to the respective grounds on each of these other two drivers. Now here's a visual of the wires leaving the power supply with the 36 volt DC going to the drivers. You're leaving on two terminals here for the 36 volt DC plus, and then the common on each of the power supplies, and they go to the actual drivers themselves and feed onto the driver itself right here. Red wire is going to volts DC plus, and the black wire goes to the ground. Hopefully you can see that okay. And it's the same on each of the four drivers. Next we have the wiring leaving the drivers going to the actual stepper motors. These motors have four wires, and two wires go to A plus, A minus on the driver, and two wires go to B plus and B minus on the driver. The way you determine that on the stepper motor, you have to find which wires are of the same coil in the motor, and to do that you need a voltmeter set on continuity or ohms, and check the continuity to see which two wires you have continuity between, and group those together, either A plus and A minus or B plus and B minus. Now once you have it hooked up and get it running, if they're running backwards, you just swap the two for the other two, the A plus, A minus for the B plus, B minus, or vice versa. So the wiring leaves the driver on A plus, A minus, B plus, B minus, and goes directly to the motor. And of course the other three stepper motors are wired exactly the same, with the A plus, A minus, B plus, B minus going directly to the stepper motor on each of the other drivers and stepper motors. Now here we are with the wires leaving the driver going directly to the stepper motor. Of course on mine I have a junction point with these connectors on the panel here, but you could run the wires directly from the stepper motor to the driver itself. Now I have two wires leaving the second power supply, one on line and one on neutral on the 120 side, 120 volt side, leaving this power supply going to a 120 volt outlet mounted into the electrical panel itself, where I have a 120 volt fan plugged into that outlet. Also plugged into that outlet is a 5 volt DC power supply that goes from here to the breakout board. Goes to one wire to ground and one wire to 5 volt. So you have to find on the 5 volt power supply, 5 volt DC power supply, you have to find out which wire is ground and which wire is the hot wire, so you can connect it correctly onto the breakout board. Also from the 5 volt on the breakout board to EN, which I think is enable, you put a little jumper wire from 5 volts to enable. And we'll take a look at that in the panel next. Here's the wires leaving the power supply for the 120 volt going to the receptacle outlet, which is right here. There's the wires coming into it. Then we have the 120 volt fan, which is just plugged directly into the outlet. And this here is the 5 volt DC power supply that plugs into the receptacle outlet, and that wire goes over to the breakout board. Hopefully you can see that, to 5 volts and ground, and a jumper over to enable right here. Now we have the rest of the wiring going to the breakout board from each of the drivers to the breakout board. You leave on pulse plus, I'm using a black wire, going to common on the breakout board. Red wire on pulse minus goes to terminal 2, and a green wire goes from direct DIR minus to terminal 3. Now from pulse plus to direct plus, we just have a black jumper wire. So again, we have a wire going from pulse plus to common, pulse minus to terminal 2, direct plus jumps back to pulse plus, and direct minus goes to terminal 3 on the breakout board. Now it's basically the same for the other 3 drivers. The next one is going from pulse plus to common. The pulse minus is going to terminal 4, and the direct minus going to terminal 5. Again, pulse plus jumps to direct plus. Same thing on the third driver, from pulse plus to common, pulse minus to terminal 6, direct minus to terminal 7, and again a jumper wire from pulse plus to direct plus. Fourth driver, pulse plus to common here between 8 and 9, pulse minus on the red wire to terminal 8, and direct minus on the green wire to terminal 9. Again, pulse plus jumping to direct plus. Now, these numbers, you could run each of these drivers to any of these 4 combinations, but these numbers become important when you set up Mach 3. You have to assign the driver for whatever motor this is going to be to the right ports in Mach 3. That's where these numbers come into play. So if this is X-axis stepper motor, then on the X-axis setup in Mach 3, you would have it going to terminal 2 and 3, and so forth for the rest of them. Now here on the actual driver is your pulse plus, pulse minus, DIR plus, and direct minus. You have a jumper from pulse plus to direction plus. Pulse minus, there's the red wire leaving the driver. and direct minus is the green wire, and also from pulse plus is the black wire going to the breakout board. Kind of hard to see the numbers. This is the first set of wires coming from the first driver going to 2, common, and 3. The same thing with the rest of them. You got 4, common, and 5, 6, common, and 7, and 8, common, and 9. So these are the 4 sets of wires leaving the drivers going to the breakout board to control the stepper motors. Now for the wiring of the limit switches. We have 3 home limit switches, one for X, Y, and Z axis. This limit switch is wired to 5 volts in terminal 15. This limit switch is wired to 5 volts, terminal 13, and this limit switch is wired to 5 volts and terminal 12. Just like the wiring on the drivers to these terminals, these terminal numbers are for when you set up Mach 3 for your limit switches, home switches. You'll use these terminal numbers in the Mach 3 setup. Now the E-stops are very similar, except you only have one set of terminals, 5 volts and terminal 10 for my machine, and the terminal 10 is set up in Mach 3 for an E-stop. I have 3 E-stops on my machine, and they're wired in series. So the wire from terminal 10 on the breakout board goes to one E-stop, and then from that E-stop to the next E-stop is a wire, and then from that second terminal on that E-stop to the next E-stop is a wire, and then from the second terminal on that E-stop is back to the breakout board on 5 volts. Now here's the wiring from the home limit switches coming back to the breakout board, and there's the terminals there. You got 12, and then 5 volt, 13, 5 volt, and 15, and then 5 volt. So those are the 3 sets of wires that are coming from the limit switches on the machine. Right here, these 2 wires, 10, the red wire, and I think that's the blue wire, 5 volt, is coming from the E-stops on the machine. Now there's one last thing I ought to mention, and that's on the breakout board. Right here on the left hand side, there's 3 little pins sticking up, and there's a jumper on there. When I got my breakout board, the jumper was on pin 1 and 2, and I had trouble getting the motors to run. In fact, they wouldn't run, and you can see that in part 8 of my CNC build videos. And until I moved it jumper to 2 and 3, they wouldn't work. So be sure, if you have a setup similar to this, you check that out. And this, on mine, the jumper has to be on pin 2 and 3. Here's the jumper on the breakout board with 1, 2, and 3. And you can see pin 1 is bare, and the jumper is on pin 2 and 3. Also, what should be pretty obvious is on the back of the breakout board, which is sticking out the back of my panel, is the 25 pin parallel port connection, where you run a parallel cord from your, or parallel cable from your breakout board to your computer. Well, I hope I've covered everything in the wiring of the CNC machine using this wiring diagram. If I've left anything out, or if you have any questions, be sure to leave a comment down below, and I'll try to answer it best I can. In the description below, I also have a link where you can download a copy of this wiring diagram. So as always, I appreciate you watching, and we'll see you next time.